Okay, well, this is part two of the Minecraft calculator. We're going to be talking about binary numbers. Now, in the last video, we talked about a lot of logic gates, and I decided before we start looking at some of the more complicated parts that put a bunch of logic gates together, we should probably talk about binary numbers. So we'll go ahead and get started on that.
In everyday life, we use a system of counting which we call decimal. So that means for each digit of a number, there's 10 different numbers you could put in there, 0 to 9. So, for example, if you've got a one-digit number, that one digit can be made of 10 different numbers. And if you've got a two-digit number, let's say the first digit here is a 7, well, this blank digit here could make 10 different numbers depending on which number you put in for that digit. So, moving on. A computer uses a different system of counting called binary. So that means for each digit, there's two different numbers that can be used. Instead of having 10, you can only have two, either a 0 or a 1. So, this system is used by computers because it only requires two different states of electricity, either on or off. So just like a switch, or in Minecraft, a lever has either it's on or it's off, a computer uses zeros and ones because you can represent 0 as being the off state and 1 being the on state. And technically, 0 is actually low voltage and 1's actually high voltage, but we're not going to worry about that. So let's look at how to count in binary. And instead of calling them digits, like in normal numbers, we have the 1 digit, the 10 digit, etc., we call them bits. But they essentially work the same way. So, this one blank is like one bit, and it can either have a 0 or a 1. So if you have a 0 there, it's 0. If you have a 1 there, it's 1. Pretty simple. And you can't count any higher with only one bit or one blank space. You can either have a 0 or you can have a 1, and that's it. Now, 2 bits. If you have 2 bits, kind of like having 2 blank spaces, there's a few things we need to know. First of all, we count from right to left. So the blank space on the right side is the first bit, and the blank space on the left side is the second bit. And that keeps going. So if you had 4 bits, you'd say the right side, this is the first bit, this is the second bit, this is the third bit, this is the fourth bit. Kind of like we said, first digit, second digit, third digit, fourth digit. Okay. So, again, we're going to have 2 blank spaces for 2 bits. And you can only have zeros or ones. So if you have 0, 0, well, that's still 0. And if you have 0, 1, that's still 1. But what about the number 2? How do you represent the number 2? Well, you would have a 1 in this bit here on the left, and you have a 0 on the bit on the right. So 1, 0. That would represent 2 in binary. So think about it like this. In normal numbering, and sorry this isn't lined up that great, but in normal numbering, each digit goes up by a power of 10. So the first digit is ones, then you've got the tens digit, you've got the hundreds digit, and you've got the thousands digit. So for example, if you have the number 1,337, the 1 is in the thousands digit, this 3 is in the hundreds digit, this 3 is in the tens digit, and the 7 is in the ones digit. So each digit goes up by a power of 10. If you notice, you have the ones is at 10 to the 0, Then you got 10 to the 1, 10 to the 2, 10 to the 3. And there's a whole math that goes into all this. In binary, each bit goes up by a power of 2. So, your first bit is like, it is a 1, represents 1. So you can either have 0 or 1 here. Highest number you can have is a 1. So 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 squared is 4. And 2 to the third is 8. So the first bit is, you can think of it as the first bit is like the 1s. The second bit is, I guess you could kind of say the 2s. The third bit is the 4s. And the fourth bit is the 8s. So you go up by powers of 2. So the fifth bit then would be 16. So 1, 0 represents 2 because this first bit is a 0 since there's nothing there. And since this 1 is in the 2s, or the second bit, it represents a 2. So 2 plus 0 is 2. Now 1, 1 in binary represents 3 because the first one on the right here is in the 1s bit. So we'd think of that as 1. This other one is in the 2s bit, so that represents 2. So 2 plus 1 equals 3. What if you have 3 bits? All right, so let's start with this 3-bit number, 1, 0, 0. Well, this 0 is in the 1s bit, and it's 0, so there's nothing there. This 0 is in the 2s bit, and again, there's nothing there. This 1 is in the 4 bit, or the 3rd bit, so it represents 4. And 4 plus 0 plus 0 is 4. So 1, 0, 1 represents 5 because this first 1 is in the 1 bit, so we'd write 1. The 0 is in the 2 bit, but since it's 0, we just put 0. And this 1 is in the 4 bit, so 4s, so we put a 4 there. So 4 plus 0 plus 1 is 5. The pattern continues. 1, 1, 0. You put 0 here. This in the second bit here represents a 2. And this one in the 3rd bit represents a 4. So 4 plus 2 plus 0 is 6. And then the biggest number you can represent with 3 bits is 7, because 1, 1, 1. You've got a 1 in the 1's bit, so you got 1. You got a 1 in the 2's bit, so you got 2. You got a 1 in the 4's bit, which is 4. So, what if we want to add numbers? Adding two binary numbers is a lot like adding two regular numbers. So, what if we want to add the number 1, 1 and 0, 1? Going back, if you remember back, 1, 1 is a 3 and 0, 1 is a 1. So 3 plus 1 is 4. Well, let's follow through the process here of how we would do this, and you would follow this same process for much bigger binary numbers. So we'll start by putting them lined up just like we do normal addition, and we'll add the numbers in the right-hand column just like normal. So 1 plus 1 is equal to 2. But in binary, we can only have a 0 or a 1, so we can't put 2 there. So we'll put a 0 on the bottom, and we'll carry that 1. We'll carry a 1 to the next column. So you can't represent 2 here, but so you put a 0, and then since this is the 2's column, we'll add an extra 1 there. So now, the second column, just like before, we have 1 plus 1 is 2. So the little one here plus this one is 2. And plus 0 is still 2. And again, since you can't put a 2 in binary, we'll have to put a 0 and carry 1 to the next column. So up here, we couldn't put a 2 in the bottom, so we carried the number to the next column. And again, since we can't put a 2 here, we'll put a 0 and carry 1 to the next column. So, whoops, redid the same picture. Okay, so here we go. So, the third column, we just have a 1. There's nothing else there. So, 1 plus nothing is 1. So we'll put 1 on the bottom. So our answer in binary is 1, 0, 0, which we've already seen is a 4 in decimal. I think that's my last slide. Yeah. So next I'll show you what that looks like in Minecraft.
Okay, so I came over to the input and output area of a little calculator. I will show you how that works later, but for now, I'm just going to show you this binary addition in Minecraft. So we've got two different numbers here, a blue number and I'm going to call it a yellow number. And each number has 2 bits. So this is bit 1, and this is bit 2. And I'm kind of calling this blue 0, kind of like 2 to the power of 0 is 1. And this is blue 1, so 2 to the power of 1 is 2. So I've got the 1's place, and I've got the 2's place. And notice how they're organized from starting right to left. And I've got the same thing over here. So this would be like the second number. And this just represents plus sign. And then over here, I've got where answers are going to come up at. So if you're adding two numbers that are 2 bits, then you could actually get a 3-bit answer. And we'll get to that. So let me go ahead and start by flicking this up. So when a lever here is down, that means it's off. And if the lever is up, that means it's on. So this represents a 1. So this would be like the number 0, 1. And the blue number here is just 0, 0. So I've got 0, 0 plus 0, 1, which gives me 1. And so if the light is on, that means we count that. And if the light is off, we don't count it. So this would be like the number 0, 0, 1, which is just 1. So we had 0 as a blue, 0, 1 as yellow. So 0 plus 1 is 1. Let's go ahead and turn this on. So now I've got 0, 1, or I've got 1 plus 1, and that gives me 2. So 0, 1, 0. Let's say I turn this into a 2. So 0, 1, 0. So I've got 0, 1 right here. I've got 1, 0 here. And now my answer is 1, 1, which adds up to be 3. So that problem that I did, walked through in the PowerPoint, was 1, 1 plus 0, 1. So 1, 1 plus 0, 1, and that gives me 4, because this light is on So this would be like 1, 0, 0 in binary. And so if I turn all of them on, now I've got 1, 1 plus 1, 1 gives me 1, 1, 0. Or in other words, 3 plus 3 gives me 6. Okay? Now, you may be wondering, could I get 7? Can I add two numbers together to give me 7? Well, I'm limited in this little calculator because the biggest two numbers I can add are what I have right now, 3 plus 3, and that gives me 6. So that is an example of binary addition in Minecraft. Okay, in the next video, we're going to be looking at how we can combine all those crazy logic gates together to make more complicated parts, which we will then put together to make the calculator. So, I hope you have a wonderful day full of laughter and joy, and I'll see you next time.